Step 15 notes. Step 15 is solving systems of linear inequalities. We're going to do that graphically. We have solved systems of linear equations in step 14. We did that graphically by substitution and by elimination. The solution of a system of inequalities is the set of all ordered pairs that satisfy both inequalities. If you graph the inequalities in the same coordinate plane, the solution is the region where the graphs overlap. So it's the double shaded region. If we look at this example, we have two linear inequalities graph. The double shaded region are where the solutions to both equations lie. So this region that satisfies both inequalities are where the solutions to the system lie. So name 2 points that are solutions to the system. So any points in this green region that I just highlighted are solutions. So I'm going to name 2 points. That one's over 5, up 3. And let's do over 7, up 0. Now, if I were to pick a point on the line, I could not pick a point on this red dotted line, where the solutions lie only above that line, not including that line. I could pick a point on the blue line since it is a solid line, and it would be a solution to the system. But to be safe, we want to choose points that are definitely in the double shaded region. Write the system of inequalities. Well, let's do the blue line first. The y-intercept, which I just marked, is over 0, up 3. So in our y equals mx plus b form of a line, b equals 3. And now I need to find the slope. So I need to choose another point that falls directly on 2 whole numbers. To get from my y-intercept to this point, I have to go up 2, right 3. So my slope is positive 2 over 3. So I'm going to start writing my equation. Y, the shaded region, is less than this blue line. It's also equal to this blue line since we have a solid line. Y is less than or equal to 2/3 x plus 3. Right, I'm going to move to this side over here to write the equation for the red line. First, we need the y-intercept. The y-intercept of the red line is at -1, over 0, down 1, b equals -1. Now I need to find another point that falls on 2 whole numbers. So to get from my y-intercept to this new point, I have to go down 1, 2, 3, 4. Down 4 and to the right 1, 2, 3, 4, 5. Down 4 and to the right 5. So I've got my slope and my y-intercept. The shaded region of the red line is above, so y is greater than, strictly greater than, because we have a dotted line, y is greater than negative 4 fifths x minus 1. So my system of inequalities, I'm going to write them together over here. System means 2 or more. Y is less than or equal to 2/3 x plus 3, and y is greater than negative 4/5 x minus 1. Three through 5, the directions are: solve each system of inequalities by graphing. Name one point that is a solution. Y is greater than negative 1. Here is y equals negative 1. It is strictly greater than negative 1, so I need a dotted line through negative 1. Y is greater than negative 1, so I need to shade above my line. I choose a new color. X is less than 0. X equals 0 here at the origin. It's strictly less than, so again I need a dotted line. And x is less than 0, so I need to shade to the left to include the x values that are less than 0. Now, the double shaded region, I need to really make sure I know what region that is. This is the region that's double shaded, so it's satisfied. These points satisfy both inequalities. Name one point that is a solution. I'm going to go left 3, up 3. Left 3. That's it. 1, 2, 3. 1, 2, 3. Yep. Left 3, up 3 is a solution to the system of inequalities. All right, number 4. Y is greater than negative 2x plus 2. I need to start at the positive 2 on the y-axis. My slope is negative 2. So I can go down 2, right 1, down 2, right 1, down 2, right 1, or up 2, left 1. I can only go in one negative direction. Again, I need a dotted line. And y is greater than this line. So go back to the y-axis before you shade. I need to shade the side that has the bigger y's. The bigger y's are above, so I'm going to shade this side of the line. Y is less than or equal to x plus 1. Start at the positive 1 on the y-axis. My slope is 1. There's an invisible 1 in front of this x. Up 1, right 1, up 1, right 1, up 1, right 1. Down 1, left 1, down 1, left 1. 2 negative directions. 2 negative moves take you in a positive direction. This is a solid line because it's also equal to this line. Right, before you shade, go back to the y-axis. Y is less than or equal to this line, so I need to shade the side of the line that is below right? And now pay special attention to the double shaded area. The double shaded area. Right? Make sure you don't go past either the line. The lines are the boundary points. All right, I'm going to choose a point that's a solution to the system. This point is a solution, and that's 1, 2, 3 over 3 up 1. And that system of inequalities is solved. All right, number 5. Y is less than x plus 1. Start at the positive 1, slope of 1, up 1, right 1, down 1, left 1. We need a dotted line. Y is less than this line. Before we graph this, we need to get it in y equals mx plus b form. I'm going to subtract the 3x over. 12 is positive, and now I'm going to divide all terms by 4. 12 divided by 4 is 3. So I'm going to start at 3 on the y-axis. I'm going to go down 3, right 4. All right, and then I would go up 3, left 4. That takes me off the graph. So I've got 2 points. That's enough to graph a line. This line will be solid because it's equal to y is greater than or equal to this line. The bigger y's are on this side of the line. Shade above. The line, and now I'm going to pay special attention to the double shaded region. Make sure I really highlight that area where the solutions lie. I'm going to pick a point that's a solution. A safe point, that one's 1, 2, 3 over 3 up 2. Right, let's practice writing systems of inequalities. I'm going to highlight this line. This is the first equation I'm going to write. Note the y-intercept. So b equals 1. Find another point so that we can find the slope. To get there, I have to go up 1, right 1. So the slope equals 1. So y, we're shading under this line. Y is less than or equal to 1x plus 1. Here, our y-intercept is -3. So b equals -3. Find another point so that we can count slope. Up 1, right 1. Slope is also 1, which makes sense. These lines are parallel. And the shading is above this line. So here we have y is greater than or equal to 1x minus 3. And we have our system of inequalities written. All right, looking at this line, it's like they both go through the origin. So the y-intercept is going to be 0. So b is going to equal 0 for both lines. We find the slope. It's like up 1, right 1 for my blue line. Slope is 1. For my green line, I need to go down and to the right, so I'm going in a negative direction. Down and to the right, the slope for the green line is -1. So writing my system, y, the blue line, is shaded above and it's dotted, so there's no equal sign. Y is greater than 1x plus 0. We don't need to write plus 0. The green line is also shaded above, so y is greater than -x plus 0. And we have our system of inequalities. One more. Y-intercept is 1. And we've got another slope of 1. So y is, this would be above this line, shading above. So y is greater than or equal to, we've got a solid line. So the slope was 1 and the y-intercept was 1. Erase this so we can get a better look at our horizontal line. Again, we have a y-intercept of 1. And a horizontal line has a slope of 0, going up 0 over however many. 0 on top of a fraction over any number is going to equal 0. The shading is below this line, so the equation is y is less than 1. And we have our system of inequalities. Notes, finish.